Hello. Okay. I just like to do that at the beginning. Folks, I unfortunately can't be here today. Maybe this week. Like, I don't know exactly what's going to happen, but like, I got this whole jury summons thing. So I had to go to the courthouse and find out when I'm sitting on a jury. It is what it is. It should be interesting. I've never done it before. But that means that instead, for today and for the foreseeable future, if I'm going to be out for a little bit, this is how it's going to be done. I'm going to record a video. I'm going to put it on YouTube. And through the glory of YouTube, your substitute will need only press play and then pause when I ask them to pause it. And I will do the rest, for I am spectacular. It's true. All right. But what are we doing today? Well, we're going to start off pretty basic. Last week, we went over the 8 characteristics of life. You should all have them in your notes. If you do not, make sure that you stop up front over here by the gas main. There's a packet that says, "What is life?" on it. And on the back of the front page, it lists 7 of the 8 characteristics of life. It is missing one, but if you don't have the notes, it is better than nothing. And last week, in order to kind of finish that up, what I had you do was I had you create your own fictional creature. And then you had to explain how it did 6 of the 8 characteristics of life. Today, we're going to start class by working a little bit backwards, by coming around the way the regents will do this, which is, here is an example. What characteristic of life does this represent? And so, ladies and gentlemen, I will present to you Marty Martian. As soon as I figure out how to do this, we're going to get the cool infinite me tunnel, which, I like. Yeah, here it comes. Yeah, infinite me is in the corner. Woo! All right, so moving on. Marty Martian, it is up front here. It will get passed out to you in a moment. It has a little Post-it note tag that says Bell 7 Marty Martian handout. And here's what it looks like. So this is basically the same thing you did, but Marty here is kind of not that bright. And so he tried to do it based on a car. He was sent to Earth to find life. He came back with a car. This middle paragraph is his write-up. This will be the important part for you to read and to understand. And basically, what's happened is the Martian government is not happy with him because they feel he did not successfully prove that cars are alive. There are 2 parts to this down bottom, the prosecutor and the defense attorney. The prosecutor wants to list out what characteristics of life did he fail to prove, which ones were not accounted for in his passage that I've highlighted right here in blue. Which ones were not there? Which ones were not present? List those out for the prosecutor. Then the defense attorney. The defense attorney says, what characteristics did he succeed in proving? So there, what you want to do is you want to go back through this and you want to read through it and try to figure out what characteristic of life are these sentences talking about. Like if one of these sentences said that he saw a car split into smaller pieces that continued rolling, that might be an example of reproduction. If he said that he watched a car as it, as it ate a deer on the road, that would be obtaining materials and energy. So you're going to have 15 minutes to work on this. You can work on this independently up front. You can work on this in the back as a group. You'll also notice, though, there are 10 total blanks here. There's only 8 characteristics of life. That means you're not expected to fill out everything. I've had people before get very anxious about there are blanks, there shouldn't be blanks. Oh God, what do I do? It's fine. There's going to be some interpretive differences that people have for what statements suggest what characteristic of life, and that's okay. So the first 5 here will be the things he did not prove. The second 5 here will be the things that he did succeed in proving. As soon as this is done, you want to put your name where it says name, and you want to get it turned in over to our blue turn-in bin. So, Mr. or Mrs. Glorious Substitute, you can pause the video. All right. So you've now had your chance. Now, just so that you understand how I would read this, and if you read this differently, that's fine. There's no problem. At the trial, Marty spoke in his defense. I first saw these life forms rolling along roads in great numbers. That line right there suggests to me reproduction. How would you get great numbers of living things unless they were reproducing? They were giving off thick clouds of poisonous waste as they moved. Not real strong, suggests something, but we'll keep going. They seem to exhibit herding behavior, as many of the cars moved in the same direction. They're responding to their environment, moving as a group. They appeared to have a great deal of energy. Some of them move faster than 60 kilometers per hour. Materials and energy, right there, it even said it. When one of these life forms stopped or slowed down, the others behind it responded. They slowed down and gave off a reddish light from the back. And sometimes they would make honking noises. That's more responding to the environment. I observed that they would stop to feed on a liquid substance. There's materials and energy again. So according to my read, the defense attorney would put down reproduction, materials and energy, and responding to their environment, which means the prosecutor could then say he did not prove it had cells. He did not prove it had DNA. He did not prove that it grows and develops. He did not prove that it maintains homeostasis. He did not prove that it evolves. Those would be the 5 that get listed there. And we're all set. Now, the next thing that I'm going to ask our glorious substitute to do will be to click on this video. How much of you is alive? And play this for the group. So you can pause me, play that, then come back. All right. It was a really cool video. I like that one because it is interesting to think how much of us is not actually us, how much of us is non-functional, how much of us isn't something that we would class alive. Hopefully some of you found that equally fascinating or disturbing. Both are totally acceptable answers. All right, so let's get on to what we're going to do now for the remainder of today. And this is going to be our introduction to the glorious world of graphing. Now, many of you have been doing graphs for years now. Science, we use line graphs. Very rarely do we bother with bar graphs or anything like that. If you take a look at graphing, the reason that we like graphing, the reason that it's held in such regard is the speed and the ease. It tells us a lot very quickly. We don't have to kind of search through data tables to figure out, it's right there. So nice, so easy. We can tell here that the dolphins in Santa Barbara have gone up since 1996. Beautiful. Much easier than trying to read out all sorts of numbers from different years and things like that. We can see here that average UFO reports by calendar month likes to spike when? When do we see the most UFO reports? During the summer months, July in particular. Does that make sense to anyone? Well, I mean, yeah. We're going to be outside the most during the summer, so we're probably going to be looking at the sky more and more likely to see weird things. We can take a look at, specifically in America, when do these UFO sightings happen? Notice they don't happen during the working hours, and they don't happen during the sleeping hours. And if you take these two pieces of data and you put them together, it makes a lot more sense. We have a lot of holidays in the summer where people are hanging out, where they're not working and they're not sleeping. And at the same point, we see these spikes in UFO activity. Weird, right? It seems like there's a suggestion. Connection, not a suggestion. What is it? All right. So as we're moving forward, you guys will be expected to do lots of graphs, and we're going to be using the TAILS system to do it. All this is an acronym so that you can follow along. And if you can check off that you've done all 5 of these things, then your graph should be fine. Full credit. Did you write a title? Did you label the axes? Did you determine the interval? Did you label that interval? And did you check it to make sure that the scale remains the same? And we'll talk about each one of these. Now, right now, you may notice there's a piece of graph paper sitting on your desk. I'm going to have you, while we're doing notes, also doing a graph. Which graph are you going to do? That data that's over on the white sideboard between the windows. A man is growing a beetle. He weighs this beetle each week for 7 weeks and records the mass. We are going to turn that into a graph today during class. So first, the title. Sadly, the titles for graphs should be as boring as possible. It's too bad, but that is literally the best approach. So for instance, right here, you can see the graph has waiting time in minutes along the y-axis. That's the vertical up and down. Day of the week along the x-axis, the horizontal one along the bottom. Which one of these two is the more boring title? Well, the second one is waiting time by day of the week, which means that is also the better title for the graph because the title has both of these labels involved in it. Waiting time by day of the week. It took part from the Y, it took part from the X. That is the best choice. How long I waited, this doesn't tell you how long somebody waited. This tells you how long people wait depending on the day. Waiting time by day of the week. So always look to do a title that mixes this axis and this one and puts them together. So for instance, right now, we need to make up a title for that data over on the sideboard. I would go with something like beetle mass by week because I can take that, squish it together. You could also say weekly beetle mass. Something along those lines. Write that on your graph paper right now towards the top edge, and we will move on. You're so talented. Now our axis, the A in TAILS. If you were not aware, it's important to note the y-axis is the vertical one. The x-axis is the horizontal one. That will be more important coming up. So it's good to know which one is which. Remember, the y-axis, it goes up, and part of the letter Y also has that vertical point to it. So those two align very well. I don't have a trick for X. It's just one is Y and the other one's not Y. All right. Now, when we take a look at our beetle data, how do we determine which one will go on what axis? Well, at least in this class and in most classes, what's going to happen is they're almost always going to be set up in this way, where your left column has some sort of regular interval and your right column is irregular. So the left one goes up by 1 every single step. The right one goes up by varying amounts. If you see that, it's important to note that the side on the left here with that regular interval, that's going to be your x-axis across the bottom, right? Weeks across the bottom. So go ahead and label that. On your graph paper for this data, write down week number underneath the x-axis, labeling it for what values will be there. And then if week is going to go across the X, that means that your right-hand column with the irregular changes, That's going to go on your y-axis, going vertically up and down. So go ahead and label beetle mass along the y-axis. Don't put the numbers down, just the words. I hope I'm like pausing the right amount of time. Otherwise, y'all are just staring at me and I'm just staring blankly back into the camera. All right, so it looks something like this. We have time in weeks and the beetle mass. That's, ignore the centimeters. I just didn't get that changed. Right, but we now have the axes labeled. Now we need to determine the interval. Now the interval is important because this tells us how many numbers are we going to need, or what numbers are we going to go by. If we take a look at weeks, it starts at 1, it goes to 7. Easy. We got to go through 7 numbers. No problem. But if you take a look at the mass, it starts at 3 and goes up to 49. That's a lot different numbers. That's significant. That's important for us to keep in mind as we move forward. All right. So once you figured those out, then we have to actually make sure that everything gets labeled. We now want to put the numbers down there. So we got to think about scale. Which one of these scales is better, the top scale or the bottom scale? Yeah, the bottom one. Why? Why is the bottom one superior? Because it's spread out more, right? It doesn't have this weird gap that you see here. This is the number one cause for students to lose points on the Regents graphing, is because there's a gap like this, because they just don't see a line. They're moving too quickly. They're distracted. Be careful. Double check. That's why scale is the last step for you to make sure that everything is spaced evenly. Now, in this class and on the Regents, you're going to be able to do this by spreading numbers out by 1, so every block is worth 1. 2s, every block is worth 2. 5s or 10s. This will work for every graph I give you this year. This will work for any graph the Regents gives you. Make sure that each block on your graph paper is either worth a 1 number, 2 numbers, 5 numbers, or 10 numbers. Not going to worry about that. So now it is time for us to actually get this graphed. We should have our title, beetle mass by week. We should now have our X and our Y axis both labeled with week number across the bottom and beetle mass along the Y. Now it is time to take your numbers for each, determine a good interval and scale to spread them out, going up and going across. As needed, pause the video for a couple minutes, let people finish this up. Okay, so now you should have all of your scales done. Now it's time to plot the points. Now it's time to make sure that at week 1, wherever you put it, you count up to wherever the value of 3 would be and put that dot. And then at week 2, count up to 7, etc., etc. Finish this graph up if you have not already done it. And then please make sure to include this graph into your notebook so that you have it there as an example. All of the data is available over on the sideboard. And this is also here as a cheat sheet effectively for the entire Tails system. It's got the little hints. It has the descriptions, the entire acronym, just waiting there for you. So feel free to pause, let people finish, and then come back one more time. All right, our last step today will be the graphing lab. Here it is. It's up front. There's a Post-it note on top of it. It says graphing lab handout, bells 7 and 8. You don't have too much to do here, just a few. First, a pie graph. I want you to analyze this. What should go where? Each of these shaded regions should represent what from this little class survey. So label it. number 2, and number 3. So Jamie bought a new video game and started keeping track of how many points he got on each attempt. Then his friend Josie tried the same game and they kept track of how many points they got. I want you to graph both of these lines on this one piece of graph paper over here. If that's not enough, there is more graph paper right up front next to the printer paper on the front desk. Feel free to grab one of those and make a larger graph so that it fits more comfortably. You're going to have 2 different lines on this. So I suggest use a marker from the back. All the markers are still out from the Living Things project at the end of last week. So grab 2 different colors. Make Jamie's line one color, make Josie's line a different color. And then when you're done with that, based on the graph, who is the better player? And most importantly, justify your answer. Explain why. What is your evidence that they are the better player? And then we're down to the last thing. Number 5, take a class survey about favorite colors. Here are your choices. No, black and white are not on there because those are hues. They are not colors, despite the fact that my favorite color is black. Anyway, you, the class, all of you, with the help of our glorious substitute, will be here and you will need to take tally of who likes what color and get those totals. And then you are going to create a graph showing it. This one is a bar graph, despite the fact that we rarely do them. They do happen. Feel free to use the whiteboard in order to tally up the blue, the red, the green, yellow, purple, pink, and orange numbers so that you folks know what you need to get done. Once again, feel free to use another sheet of graph paper. When you're done, make sure that they're all together. The stapler is up on my desk with a Post-it note that says stapler. And feel free to use that. Staple them all together. It's a Kerchungi staple. It doesn't, you don't like put it down and push on it. You hold it like a staple gun and kind of go and it closes, clamps, and staples, just in case people get confused every year. And that will be your lab for today. So for the lab, once again, label the pie graph based on the values over here. On this line graph, you're going to make 2 separate lines. One for Jamie, one for Josie. Tell me who's a better player and justify that answer. And then finally, as a class, get a survey and make a bar graph to show what are the favorite colors in this class. Yes, you got to pick one, folks. Just pick one. I recognize you might have 2 or 3 favorite. Just pick one. All right. That is your assignment. If you have extra time beyond that, finish the Living Things project if you have not yet finished it. Finish the airplane lab or the gummy bear lab. We still have people whose gummy bears are sitting in that back cabinet in their tiny little beakers that by this point have completely turned into goop. But get your data so that you can get it turned in. I hope everyone has a great day. Looking forward to seeing everybody again tomorrow. If I don't, and I'm out for this jury duty thing for a while, it will be videos like this that I'll set up in the morning. Your substitute will come in and hit play, and then I will lead you as I do. Ladies and gentlemen, have a great day. That's not it. There we go. Stop presenting. Have a great day, and I hope that I'll see you soon.